Thank you all for joining us today. We're going to go ahead and get started now. My name is Janet Van Zorn. I'm the support specialist for the New York statewide viticulture extension program, and I'll be your moderator and will provide technical support today. A quick announcement that this is the last webinar in this Northern Grape Project's webinar series, but please stay tuned for updates on future webinar series. And if you're not yet subscribed to the Northern Grapes Project listserv, you can sign up to receive email notifications of upcoming webinars there. You'll find the information on how to sign up on our website at www.northerngrapesproject.org. To start off today, you can open the chat bar at the bottom of your screen and use it for introducing yourself, making any comments, and to alert me if you're having technical difficulties. Just change the chat settings to send to all panelists and attendees so everyone can see your introduction. If you'd like to ask questions during the presentation, please use the Q&A button on the menu at the bottom of your screen. We'll have time at the end of the presentation for questions, but you can type them in at any time during the talk. Additionally, Megan will provide her email address so you can email her directly to ask any vineyard-specific questions or any that we don't get to today. Our speaker today is Dr. Megan Hall. She's an assistant professor in the Division of Plant Sciences and Viticulture at the University of Missouri. Her research program focuses on the grape microbiome. Today she will be talking about the complex insect and microbial interactions that affect sour rot in grapes. And I'll now turn it over to Megan. So I'm going to just stop sharing and you can go ahead and share your screen.
Alrighty. How does that look?
There it is. Looks great.
Okie dokie. All right, and everybody can hear me okay?
Yep.
Probably? Okay.
Nice and clear.
All right, great. Hi to everyone. You know, as I'm watching everybody stream in here, talking about the terrible weather that everyone collectively is experiencing. Here in Missouri, we had an ice storm overnight. So, you know, this has been one crazy kind of winter. Yeah, so I'm really glad that I was invited to do a Northern Grape seminar. I think this is just a fantastic way of being able to reach a whole bunch of different people at once. I usually try to pick a few conferences to go to in the winter time and speak at, and it's always really nice to speak to a particular industry and understand a particular industry's needs, but it's a lot of fun for me to be able to speak to a bunch of different people from a bunch of different places all at once and kind of see you all interact and get to talk to you about one of my favorite topics, which is sour rot. So I'm going to talk to you today about how this project came about, what we've done to understand this disease, and talk about management, which I know is a big priority for all of you. So I appreciate you coming today. If I can turn the page. Okay. So here's how we're going to go through this. I'm going to talk about what sour rot is, and I assume for most of you that are here today, you know what sour rot is, which is why you've come to understand a little bit more about it. But for those of you who don't know what it is and haven't seen it in your vineyards, we're going to cover that first. I'll move on to how we manage sour rot currently, you know, the management strategies we've developed, and then focusing on how often we should spray, which is a big question for all of us in the research community as well as the growers I work with. So, and then I will have time for questions at the end. So what are the symptoms of sour rot? So there on your left, you can see a cluster of vignole, which is an interspecific French-American hybrid with sour rot on it. Typically, we see this develop on tight, clustered, thin-skinned grape varieties, thus the vignole. So for those of you who grow vignole, this is probably something you have seen quite often. But I have seen sour rot on a very wide range of cultivars, Riesling and Cab Franc, just a number of different ones. So it's quite common kind of across the board. Berries start to show discoloration about 15 bricks. For some of you, that's 2 weeks before harvest. For some of you, that's more like 4 to 5. It kind of depends on where you are and what your weather is. And, you know, those weeks before harvest, sometimes things can get a little crazy, as you all know. So there isn't a specific schedule for these things. is associated with having a wound site, and sometimes that wound site is really obvious from the outside. It's it can be something like a hole caused by a yellow jacket, or it can be something that's less obvious to you from the outside. It can sometimes be because those berries are pushing up against each other and they're separating from the pedicel inside the cluster. So if you were to kind of break open that cluster, push apart those berries, you might see that they've separated sort of at that inside part instead of somewhere on the outside where it's more obvious. The obvious one is it smells like vinegar, which is the sour in sour rot. And so there is this smell of acetic acid that emanates from the cluster. And, eventually, if, you're progressing enough, I've been to vineyards where I've gotten out of the car and I can smell it just emanating from the entire vineyard. So it's pretty potent, and it's pretty recognizable as well. One of the key components, and this separates sour rot from a lot of other understudied late season bunch rots, is that there is a loss of berry integrity. So that pulp eventually starts oozing out of those berries and kind of down the cluster, and eventually hollowing out some of those berry skins so that we don't really see any pulp on the inside anymore even. And then, of course, there is an association with Drosophila fruit flies. And these are just your run-of-the-mill melanogaster that we see if we leave a banana too long on our kitchen counter. And they are typically buzzing about these clusters, and kind of have brought us an interesting problem, which I'm going to talk about, that is why this is such an interesting disease complex. So and this was all part of my PhD work at Cornell, and I'm continuing it now here at University of Missouri. But part of what we did when we started out this project was trying to understand what sour rot is and also what it isn't. And that can be kind of confusing, but part of the reason why we need to know what it isn't is that there are a lot of things that can affect berries when you get close to harvest. And, we can easily recognize things like botrytis, but when it came to 5 years ago when we started this project and we didn't know what sour rot was, we kind of needed to understand what the symptoms were so that we could say, okay, this is sour rot, but that other thing over there is not sour rot. And, I'll sort of deal with some of those things later. So the definition that we established of sour rot, which helped us go forward, was that it's a syndrome that consists of both the production of acetic acid, that's sour and sour rot, within the necrotic berries, and then this loss of berry integrity that releases the pulp from the inside of the berry. And that's really a key component. And you can see from this lovely picture here on the left-hand side, you can see those fruit flies walking. I don't know if you can see my cursor, but you can see these fruit flies walking on the surface of the berries. So this is their home. They're very happy. And down here is one of those strange wound sites that we see that kind of originate from inside the clusters. So when we first started this, and this was back 2013 through 2015, we wanted to know, is that smell that we're smelling, we think it's acetic acid, but how much is there? Is it really acetic acid? And we also decided to answer, whether we could actually detect ethanol in these berries as well, partially because ethanol is a pretty common precursor to acetic acid. And so generally, if we have acetic acid, we can detect some ethanol as well, and that could lead us to understand a little bit more about this disease. And part of the reason that I'm going to lead you through how why we need to know how this disease works in order to understand how to manage it is that they are directly related. And I think you'll see some of this as we go along. So this was a collection of field samples from the Finger Lakes, from many different commercial vineyards from 2013 through 2015. We analyzed them via HPLC, and basically what we see is that there is somewhere between 1 and 3 grams per liter of ethanol in these grape berries, along with anywhere from 0.95 to over almost 2.5 grams per liter of acetic acid in these grape berries. And just for context, that's a lot. So we don't really want to see that much ethanol or acetic acid really building up in berries that haven't even been harvested yet. And that smells very potent. So that's something that you can recognize right away when those berries get anywhere close to you. So we want to know kind of how it got there. How is that acetic acid forming, and what's the relationship with ethanol? So we took a bunch of grapes, we inoculated it with what we saw as sort of the most obvious way that it could get there, which is yeast. You know, we know yeast produces ethanol, and some acetic acid bacteria, the bacteria that produce acetic acid. So we inoculated different berries with yeast and acetic acid bacteria and added flies or left the flies out because we know that they're associated, but we don't know how. And I macerated them on a day-to-day basis just to see if we could track this ethanol and acetic acid. And over a 5-day period, what we see is that the ethanol starts to build up in a lot of different these different treatments, and that by day 5, you know, the one that the arrow is pointing to is this inoculation plus flies treatment that we included the flies in, and we can see that it starts to build up and then it tapers off a little bit. We're curious about this, but if we look at the top line where the inoculation was included but not the flies, that line does go straight up and keeps climbing. So what happens to this one when we look at the acetic acid numbers? Well, it turns out that it looks like it's being converted into acetic acid. So with the inclusion of the flies, suddenly we don't just have ethanol hanging out in our grapes, we suddenly also have acetic acid that's being converted. So on a brief tangent and topic of another talk that maybe you guys will hear me do some other time, is that we found that there was ethanol in this untreated control. And this was pretty curious for us as a group of researchers. And what I ended up finding was that these yeast and bacteria that we were inoculating with, it turns out the grape insides are already teeming with these organisms. And so this is a really complicating factor for sour rot, partially because we are looking for quote unquote pathogens that are ubiquitous in nature. So the things that are causing this are already living on the insides and on the surface of the grapes. So, and this was, you know, a topic of a paper that came out in December, of just recognizing that the insides of the grapes are really home to a lot of these organisms that are responsible for this disease. And that just to drive home that ethanol, and in some cases acetic acid, is already accumulating within healthy grapes. And so how do we mitigate that? And that's something that we're trying to figure out how to deal with too. So part of the definition of sour rot is that we included was that samples had to include a certain amount of acetic acid in order to be considered sour rot, and not just the presence of any amount of acetic acid was going to get it recognized as sour rot, because it was actually pretty common for us to find some level of acetic acid on very low levels in healthy looking grapes. It's obviously a complicating factor. So we did do some pathogenicity experiments. Most of these, we bought type cultures from the American type culture, and we got yeast and different acetic acid bacteria, and we just basically did a lot of different inoculations to see if we could cause symptoms. And what we got was a lot of really confusing data where we had lots of ethanol, we had lots of acetic acid, but we didn't always have sour rot symptoms, which was really confusing. We just figured, hey, if we have ethanol and acetic acid, that must be what sour rot is. Well, it turns out, once again, these things are ubiquitous in nature, and we find them all the time, and it doesn't necessarily mean that we're going to get symptoms. So, these acetic acid levels in some of these grapes, we were inoculating, and we were having perfectly healthy berries at the end of the experiment, despite the fact that there was acetic acid developing in the berries. So we added another criteria for defining sour rot, and that was this loss of berry integrity that I've talked about a little bit so far. So the berries collapsing on themselves, because after the pulp liquefies, it drains out, and then you're left with this shell. And that is really characteristic of sour rot. And so we included that in the definition because that was really a defining factor of what sour rot was, and also helped us explain what sour rot wasn't. with that, we had to develop a rating scale, and we felt that really after you get past this level 3, which is, the berry's lost its turgor pressure and really the majority of the skin is discolored, this is sort of your early stage of sour rot. And after that is when you go into this inner pulp liquefying and leaking out and the skin completely discolorating, complete discoloration of the skin. So classic sour rot symptoms, and you can see those here on the left. So we partnered these two criteria up. So to be considered sour rot, you need to have this, disease rating of more than 3. So in other words, you need to see this loss of integrity, and it needs to be partnered with enough acetic acid to also be considered sour rot. So we use this information to combine the results of our inoculation experiments, which I showed you before, showing the acetic acid accumulation, with the disease ratings. And you can see the ratings here on the 0 to 4 scale on the sides. And the black ones are actually the only places where we get 4s, so sour rot symptoms. And only 3 treatments satisfied both of these criteria, and that's when we had a yeast, an acetic acid bacteria, and we had Drosophila. If we did not include flies, we did not get sour rot symptoms. We really wanted to know if these flies were making a microbial contribution that we were missing. So is there something that the flies had on their bodies or in their guts that they were bringing in that we were missing? And that we weren't including in our inoculation experiments. And so we decided to, with the help of a few other labs at Cornell, make azenic fruit flies, which means that they were missing their gut microbes and their surface microbes. And so basically, it's not an overly complicated process, but it's a little tedious, where you remove the outer layer of the Drosophila egg and you raise it in a sterile environment. So it eats sterile media. And they do behave pretty strangely. So you can imagine if someone take away our gut microbes, we might behave a little oddly. So those are the flies that we used going forward, so that we were sure we weren't including something in the assay that we weren't planning on. So we then redid some pathogenicity experiments, again with these type cultures of acetic acid bacteria and yeast, and we included or excluded azenic melanogaster. And what we found again is that we get this acetic acid accumulating in the presence of these flies. So that there's something else going on here. Basically, when we partner with these inoculations with the Drosophila, when we have the organisms with the Drosophila, yeast, an acetic acid bacteria, and a fruit fly, that's when we see these sour rot symptoms develop. And when we don't have flies included, it just doesn't happen. We wanted to know, again, just to be sure, because this is kind of weird. It was shocking to us to find out that these flies may be playing a role in actually causing this disease. This is pretty uncharted territory, and we wanted to be really sure that there wasn't something that the flies were bringing in. And so I created what I called wild type inoculum, this WT inoculum. And basically I took some wild type flies, just your run of the mill fruit flies that were full of microbes, let them walk around on some media for a few days, then flooded the plate with some water and kind of created a slurry, and then used that to inoculate some grapes. And we either included azenic fruit flies, or we didn't include the flies. So this would give us an idea of, is there something that the flies have that is causing these symptoms, or is it the physical presence of the flies and something they are doing to the berries that is causing this disease? And what we found was that the inoculum alone did not produce symptoms. If we included the azenic flies, that's where we got sour rot. That's very important. So to kind of drive that home for you in giant letters, the microbes aren't sufficient for symptom development. We need the flies. And so why have I taken you through this entire big thing, is to say, if we know that flies are required, then we also know what to target. If we were just, when I started this project 5 years ago, there were products labeled for sour rot on the market, but they were antimicrobials. There was no word of flies being the causal organism. And so, you know, this allowed us to understand what we were going after and how to finally control this disease. So we wanted to actually take this one step further, because up until this point we had used these type cultures. And so I went around to vineyards throughout the Finger Lakes and actually took washes of all these different berries and ended up with like 1,600 isolates of different things that I'd found on sour rot affected berries. And I boiled them all down to what organisms again and again were associated with these sour rot symptoms. And what I found was that Gluconobacter was found again and again in almost 90% and 100% of the samples in 2 years. We had 2 different Mentionicauia species, yeast species, and then we had this other environmental bacterium that is quite ubiquitous in the environment. And these ones we found in a very high level. They were the most common organisms associated with sour rot. And so once again, we repeated these pathogenicity experiments with these field isolates and the azenic melanogaster. And once again, we see that the acetic acid threshold is reached by all the samples that include the azenic flies. But then when we partner it with, once again, those disease ratings, we see that we need a yeast and we need the acetic acid bacteria and we need those azenic fruit flies. So hopefully I've convinced you by now that, you know, we need all 3 components. We need an acetic acid bacteria, a yeast, and a fruit fly in order to cause sour rot, and that the yeast and the bacteria are already present in and on the grape berries. So that provides us with a pretty complicating factor from a pathology standpoint, that this is not just about not letting it in. They are already there. So we're almost constantly doing some management, like how to manage this is just is a big feat. It's not an easy thing to do. So we are still working on what contribution the Drosophila is making, and I'm going to talk a little bit more about that in a minute. But we also know that it's not microbial. It's doing something else. So managing sour rot, which I know a lot of you are here for and want to know more about, we ran 3 years of disease control trials, 2013, 15, and 16, in a plot in Geneva, New York. And we were using we used 2 different insecticides, one in 2013 and a different one in 2015 and 16. And then we partnered those up with antimicrobials. So potassium metabisulfite, which is not labeled for use in grapes, but we had anecdotal evidence that it might be worth looking at. Oxidate, which is labeled for use in sour rot, fracture, and we then played around with some different spray timings. So what we can see here is that the inclusion of insecticide is really what made the amount of severity greatly reduced in some of these treatments. And so really starting even with the untreated control on the left-hand side, we're experiencing close to 30% sour rot in the untreated control with no insecticide. If we just include the insecticide only, we're bringing it down to 10%. So that is a huge reduction without even adding an antimicrobial. And so here we have an antimicrobial that we've added. This is pre-symptoms, so this is before we start to see symptom development. Here is a single spray at 15 bricks. And then there are post-development sprays as well. So this was our most successful treatment, that no significant control with the antimicrobial alone, but this antimicrobial with insecticide sprays applied before symptoms reduced the severity by about 15% over the control. And we see this again and again in various years, that insecticide had a significant difference on the amount of severity in every year in which we conducted these trials. The antimicrobials only worked in 1 of the years, and the antimicrobial by insecticide was significant in 2 years. So the insecticide was working every year of these trials. to understand, to make sure that we were controlling Drosophila and not something else that we were looking for, we looked at the number of melanogaster from each treatment panel, and this was in 2015, in which we didn't use insecticide. We looked at those same spray treatments. What we found is that in the insecticide-treated panels, we basically don't see any melanogaster. In the no insecticide panels, we do indeed see those melanogaster numbers. For those of you who have questions about Drosophila suzuki'i, which is the spotted wing Drosophila, it's a very popular topic right now, is that we decided to rear out the number of suzuki'i from each of these panels as well. We know that a lot of people are concerned that suzuki'i is responsible for sour rot, and we hadn't seen any evidence of that, and we wanted to check to see if we could rear them out of these panels in any different kinds of numbers than melanogaster. Now, what we just found overall was that we had a really, really low number of suzuki'i. These numbers, if you look at the scale on the left-hand side, that's one fly. It's not in the hundreds or thousands, that's a single fly. Even in the untreated control, we get 5. So these are really low numbers. These did not make us feel like that suzuki'i was really responsible for this, this disease single-handedly, that it was more of a pan-Drosophila issue. So most of the Drosophila reared from treatments without the insecticide, and the total number of melanogaster reared from the treatments was significantly larger than the number of suzuki'i we reared from these same treatments. So what does this mean? So it means if you're going to apply either an antimicrobial or an insecticide to treat sour rot, put on the insecticide. If it's a money issue or a time issue or whatever the case may be, the insecticide has always been proven to be effective. So this was our most effective treatment, this 1% oxidate tank mixed with Mustang Max, starting pre-symptoms and then applied weekly sprays thereafter. And this is one that a lot of growers have been using with success for the last few years since we started coming out with this data and started kind of peddling it around at conferences and things like that. We had a big but occur this summer, and that but is that in 2018 Mustang Max resistant Drosophila were identified in the Finger Lakes. This is a big deal because it means that we are losing one of the tools that we know can help us control sour rot. And if we have resistant Drosophila, we don't have a ton of tools in our tool belt to begin with. And so one thing that I need to communicate clearly for all of you is that we have to be rotating insecticides when you can. That being said, there aren't a lot of options. So Mustang Max, I just put these up here so that you can all see, is the one that we used with the most efficacy, the highest efficacy, which is group 3A, which has a 1-day PHI, which is obviously the best, especially since we're dealing with a late season bunch rot. This is, the last 2 critical weeks before harvest. A lot of other people are using Delegate. I believe those Drosophila that were identified in the Finger Lakes were also resistant to Delegate. But this, that's another tool in your toolbox that you should be using instead of just pummeling it with Mustang Max. That PHI is 7 days though. The other option, and this is not going to be true for every state. I know it's available in Missouri, but I do not think it's available in New York. But you should check the labels for your state, is Venom, which has a 1-day PHI and is a group 4A insecticide. And so, I can't emphasize this enough that we are developing management strategies and things that do work. But if you develop resistant Drosophila, we're not in a place yet where we have a lot of IPM options. And so this is the next phase of our work, and we are really focusing on getting more options for people, but it's tough. So I'm going to talk a little bit about sour rot severity by Trellis system, and I'm going to, in the next phase of my talk, I'm going to talk a little bit about spray timing too. We had anecdotal evidence of a commercial vineyard in the Finger Lakes that had it had 2 different plantings of vigneol, one on VSP right next to a planting on high wire. and I worked a lot with the grower there. And he at some point said, I just think I'm getting more sour rot in my high wire. Is that possible? I'm like, sure, it's possible. Let's go figure out if it's something that's happening consistently. So from 2014 to 2016, so 3 years in a row, I took a random selection of vines, and then twice weekly disease severity and incidence ratings on those vines. And what we found, I'm just going to show you the one data set from 2015, is that we saw, or 2016, that we saw consistently higher severity at every sampling point in the high wire planting. And that this was not, we saw consistently lower ones in the Vigneal, or the VSP, of course. So I show you this one too, because this particular grower applied one single spray of KMS and Mustang Max at one point about a week before harvest. And I can say with some confidence that this increase would have kept going up, or we can expect that it would have kept going up. But that one single spray that was applied did seem to kind of curtail symptom or disease severity. And that's pretty much where he ended up harvesting, is at that same amount that he had after he sprayed, or before he sprayed, sorry. This was consistent across all 3 years of the study, that we consistently saw more disease in the higher wire system than the VSP. Sorry, just one more note about that too, that I often am asked why I think that's the case. And one of the reasons I think it is the case is that for those of you who have vines trained to a high wire system, the system, or it kind of creates sort of an umbrella over the vines in a certain way. And that umbrella underneath, if you kind of poke your head up there, that's a pretty warm, humid environment with not a lot of air circulation. Whereas the VSP vines don't really have that same umbrella effect, and they aren't really seeing that same level of protection in the fruit zone. The problem with that level of protection is that it's a great place for microbes to grow, and the fruit flies can fly around without worrying about being pushed away by the wind, or they're just very happy to live in that environment. That being said, we started to put a little bit of data behind that a couple years ago, and we haven't continued with that too much. We may in the future, but I don't have hard data to show the reason that I think that high wire has higher levels of disease severity than the VSP. So for those of you who have had sour rot in your vineyards, this is obvious to you that sour rot can progress very quickly. But I like to show this data, and this is collected in Hobart, Tasmania. In a commercial vineyard, they do not have any insecticides that can be sprayed that close to harvest. So I think the soonest PHI that they can use is a 30-day PHI, which, it doesn't work very well for sour rot because that's happening within that window. And so I just took disease incident ratings every 5 days until harvest in a commercial vineyard over 2 weeks, or over 10 days, sorry. And these, you can see on a couple of days, and this is, not very long at all, we go from somewhere like 22% severity all the way almost up to 60. And from a severity standpoint, 7 up to over, about 26. This disease can spread really quickly. And so once you have that initial infestation, that's when you start to see really very quick spread over time. One thing that they did do, which once I realized they were doing, told them, please do not do that, is they were dropping the diseased cluster, the symptomatic clusters under the vines, just dropping them right on the ground. The problem with this is that you're not removing the problem from your vineyard. Those fruit flies are just living in those grapes, and when they're done with those, they fly right up to the other grapes in your canopy. So if you do, decide to cut off clusters and to kind of mitigate the damage that way, remove them from your vineyard, get them out of there. We don't have data to show how far from your block you should remove them. And we do know that, fruit flies can overwinter in leaf litter and things like that. So but getting them out of your block and as far away as possible from any cultivars that could be affected, that's really important. And especially don't just drop them in the rows or under the vines. It's a terrible idea. So yeah, just to put it in bold letters, remove the clusters from your vineyard if you can. So the take home on this, just mostly that the combined use of antimicrobial and insecticide sprays, especially when applied before the onset of symptoms, is what provides the most effective control of sour rot, and that this insecticide application results in the reduced number of Drosophila. We're not seeing spotted wing as a major player, and good management strategies to remove them from your vineyard. So there's a lot we still don't know, and this is new research since I came to Mizzou. This is my new master's student, Patrick Kenny, who started in the summer. And so we have a little bit of preliminary data from Patrick from this fall. And some of the preliminary questions we wanted to answer with him was, can we determine what fly life stage is causing sour rot, which might seem like a minor question to some of you, but really, if we're kind of playing catch up here, whereas every time we start to spray, we seem like we've already kind of missed the boat. And so is it possible that we need to be targeting an earlier life stage, or we need to be doing something before this infestation even starts in order to control the disease? And what would that be? And then the other question is, what is the best timing to spray, especially if we know that really we can't afford to be spraying weekly like we recommended before, because we're dealing with resistance issues. And so if we need to get that number of sprays way down, what's the magic number? When do we spray? How often do we spray? And we need to fine tune this somewhat, because we know that these weekly sprays are leading to disaster, honestly, with resistance. They're doing a great job controlling sour rot, and I hear that from so many people all the time, like, it solved my sour rot problem, but now we have resistance issues to worry about. So we need to fine tune this. So he did 2 new experiments this fall, and I want to just highlight that these are both preliminary data, but I think they're both important to share. One of them highlighting sour rot severity and the correlation with adult flies, number of adult flies, and the other one involves spray timing. So in the first experiment, we wanted to know if we could correlate sour rot and fly number. And Patrick went around to vineyards throughout Missouri and basically placed them in a sample cup to see if we could see if sour rot severity itself was linked with fly number. So we know that symptoms progress over time, but does that actually have anything to do with the fly number growing, or is it independent of the number of flies? And what we found was that there is a very significant interaction between fly number and sour rot severity. And what we found, this basically goes that after 2 weeks, when we're up to almost 90% severity in some of these, if we've got almost 100 flies being reared out of all of these berries. And the reason that there's a 0 in this first one is that when he collected them, obviously the flies fly off of them, and so there's no first number associated with that. But we could see that by the end of week 1, we're over 40. By the end of week 2, we're 90. So we've significantly correlated fly number with sour rot severity for this first year, and I'm going to emphasize that this is preliminary results again. So what? Why do we care? Seems like a kind of a duh factor thing too. Well, if we're looking at controlling this initial fly number, then we should be able to control severity, right? So maybe we're dealing with it too late. If we're spraying or starting to spray for sour rot after we already see symptom development, we're not accounting for the number of larvae that are actually already in those clusters and what's going to be reared out over the next few weeks. And that's really where it might be really dangerous. And this is what we're looking at. So how do we reduce that initial infestation of Drosophila? And so in 2019, we're going to also be counting larvae in those collected berries, just to see if we can correlate it with, you know, the number of larvae that's actually in those berries when we collect them, to see if we can do something starting earlier. If we can prevent that initial infection, maybe we can control the whole thing. In the second experiment, we looked at post-season sour rot sprays, and part of the reason we chose post-symptom is because there's a lot of growers who do not want to start spraying for sour rot until they see evidence that it's happening, and I don't blame them. Applying unnecessary materials on your grapes is big cost. It's also a big time suck, and you know, a lot of people just want to wait until they say, okay, this is going to be a problem in this particular variety this year, so I'm going to start spraying after I start seeing symptoms. So we partnered with 2 commercial vineyards here in Missouri, and we did 3 different spray treatments. You'll note that we don't have an untreated control, mostly because these are commercial operators, and if they don't spray for sour rot, then they don't get to harvest their blocks. So our control treatment was actually our kind of industry standard at this point, which is weekly sprays beginning at 15 to 16 bricks. So we included that in the treatments, and then we compared this to 2 sprays, one at 16 bricks and one at 20, and then a different treatment where we sprayed at 16, 19, and 22 bricks. Okay, so just to recap, we have 1 spray, 2 sprays here, 3 sprays here, and somewhere around 4 to 5 sprays in the weekly sprays. Just how it worked out in 2018. At harvest, we rated this for sour rot incidence and severity. And here's how it turned out. So, okay, in one of the commercial vineyards, and just to show you the spray schedule, in one of the commercial vineyards in St. John, you can see that we get our fair share of rain here in Missouri during harvest. And so leading up these weekly sprays, there were 4 weekly sprays in this vineyard. In the other commercial vineyard we partnered with, they had 5 weekly sprays. And so you can see how that spray timing worked out a little bit. What we see, and this is again preliminary data, 1 year of data, that multiple spray applications after the start of symptoms didn't substantially impact the severity or incidence. So we can look down here and look at severity incidence. Severity here with the weekly applications ends up being about 15%. With just 2 sprays, it's right at 15%. And with 3 sprays, it's within that same, 15 to 17%. This is not a significant difference between these 3 severities. And the incidence, honestly, is not impacted significantally either. So this was really eye-opening for us to go from, okay, we know that weekly sprays work. Well, this first year of data shows that 2 sprays work just as well as 5. And that is a really big deal for us to know that, and also for growers to know that, that we could be getting somewhere and not having to apply as many sprays as we have been applying for the last couple of years. So this, again, preliminary results, and I just think that this is really important data to share, which is I wouldn't normally share around data that we only have 1 year of, but this I think is really important data for everybody to have. So I qualify this by saying that this is in these 2 vineyards in this 1 year, but that applying 2 sprays was just as effective as these 4 to 5 weekly sprays. So we have new questions that have arisen from some of this too. How do we prevent this initial infestation of fruit flies? We are really interested in this question, and I think Patrick may even stay on for his PhD because I think he's becoming invested in this question as well, that targeting this larval stage might be key. And I don't know how we're going to do that yet, but we're looking into a lot of different strategies, IPM strategies especially, that might allow us to deter or do something that would prevent that initial infestation of flies. And then, what again is that best spray timing, and how few sprays can we really get away with, especially knowing that spraying every week isn't necessarily giving you more control. Okay, so to recap everything I've just gone through, we've defined the disease, and that's pretty exciting over the last 5 years to say, that we know what sour rot is. And again, that means that we know what sour rot isn't. So you'll know it now, hopefully, when you see it in your vineyard. And we've determined the causal organisms. We know that a yeast, acetic acid bacteria, and Drosophila have to be present in order to cause symptoms. And we know that effective disease control involves targeting microbes and Drosophila, that applications of both antimicrobials and insecticide sprays together work well, or just insecticides on their own. Hopefully, probably or preferably pre-symptom development, but I know that that's not always possible for everyone. Don't drop your clusters on the ground, and more sprays apparently don't necessarily equal better control. And hopefully we'll know more about that this coming year, and I can't wait to share that data with you guys, because I feel like that's so important for how we're going to move forward. So with that, I want to thank all of the cooperators that I worked with at Cornell, and also now at Mizzou. I've got a great team here and a lot of wonderful people to work with, and it's been a really fantastic experience in general. So with that, I will take questions if you have them, and yeah, thank you.
All right, great. Thank you, Megan. That was really interesting. I have a few questions already in the question and answer bar, so I'm going to go ahead and get started on those. But
Sure.
if anybody else has any questions, just go ahead and type those in, and we'll get to them as we have time. One question was about the timing of the actual infection, and I believe maybe you were kind of saying that that was earlier in the season more often, but can you just speak a little bit about sort of the life cycle of the flies and the disease agents and how those play out throughout the season?
Yeah, so I've found yeast and bacteria inside the grapes as early as pea-sized berries. So these organisms are living inside the berries from the very start of the season. And so there is no moment at which they suddenly become pathogens. They are living in the grapes. They are part of the microbiome of these grapes.
Mm-hmm.
The flies, however, are really, they become an issue in those last few weeks before harvest, partially because I think we get more wound sites, so those berries are pushing up against each other. And then also the sugar levels, I think because the yeast start fermenting those sugars inside the berries into ethanol, and they attract fruit flies. They're also attracted, but the wound sites then provide an oxygenated environment in which the ethanol can turn into acetic acid. That acetic acid also attracts fruit flies. And so we're honestly kind of in a chicken and egg problem, that we know that all of these things exist kind of all the time. It's more just fine tuning how and when we can deal with them in the vineyard. So, and part of that is, berries splitting is a big indicator for us that we're going to get sour rot. And that's, those wound sites seem to be where things really go south.
Okay. Another question, Annie Claude was wondering if you had more information specifically about that Finger Lakes resistant population, or if you had a link that people could read a little bit more about that.
I do not. I got word from Hans Walter Peterson,
Mm-hmm.
who I can't remember if I know he sent out an email. I don't know if it went out in any bulletin or anything like that, but I know it's not a secret.
Mm-hmm. Yeah.
So that information is available somewhere. I can't say that I personally.
Okay. I think I suspect that possibly we've written something about that in the Variation to Harvest
Very
newsletter, but I
possibly.
can't say exactly where it is, but that can maybe at least send people in a direction.
Yeah, we don't have, and I'm working, Greg Loeb and I have talked a lot. We are committed to trying to figure out some solutions too, because, I started this work in the Finger Lakes, and it pains me to see that there is resistant Drosophila in the Finger Lakes. So I'm very committed to figuring out if we can figure out a solution. But all the information that I have is, I think, what's been disseminated, just that there is resistant Drosophila in the vineyards. Yeah.
Okay, thanks. Another question a couple people asked about was whether malathion is another option of an insecticide, and if not, why not?
I have heard anecdotal evidence that malathion has worked for some people. I don't have a lot of information about that either way, but I have heard from a couple of growers that they have used it with success. But it's not widely used here, so yeah, can't.
Okay. Okay, and on a similar line, James Skinner asked whether Liquid 7 would be as effective as Mustang Max.
Oh goodness, I don't know the answer to that. That would require me doing a bit of Googling, I think.
Okay.
I don't know the answer off the top of my head. I'm sorry.
Okay, that's fine. Maybe if somebody if he wants to send an email to you to
Yeah.
follow up, or to me
Yes.
also, that would be fine. We can look
Yeah.
into that more.
Feel free to send an email. I'd be happy to look up some information on that for you.
Okay, excellent. Another question from Charlie Rosa Bianca is whether you have done research on the release of, I might say this wrong, but pectolytic enzymes released by the Drosophilids in the berries that would increase the severity.
That is what we're doing. So we're actually really, that's what we're looking at, is we think that it's probably an enzyme that's being excreted by the larva in the berries, either through their mouth parts or through their frass. And that's what we think is happening, but we're trying to run the experiments to actually get some data behind that.
Excellent. So stay tuned.
Yeah.
Another question is whether sour rot tends to be present from year to year in the same location, or does it tend to sort of be a little bit more random or sporadic where it is?
So I would say that people that I know that have sour rot consistently see it in certain cultivars, and in blocks that tend to be located beside woody areas.
Okay.
So that, we know some stuff about Drosophila overwintering or where they live or tend to like to be, and that tends to be more wooded areas. And so it would follow that having a block right beside a wooded area probably wouldn't be the best for sour rot. However, that's also, it's got to be a susceptible cultivar.
Sure.
So there's a lot of things that come into play, but usually if a grower sees it, in their Gewurz every year, or so in their Gewurz block, they're usually going to see it every year in that Gewurz block to some degree. And that's going to be somewhat weather dependent. If it's a bone dry year and you don't get a lot of splitting, but if you get, I don't know, a boatload of rain at harvest, yeah, suddenly it's a different story.
Sure. Okay, but it sounds like maybe it more has to do with sort of resistant versus susceptible cultivars and less having to do with sort of like something overwintering in the vine. Drosophilas are pretty willing to just kind of move around, so maybe that's less of a concern.
So I'll also say too that Drosophila aren't really interested in grapes until the end of the season. So there's other things, especially if you're in an environment where you have berries, small berries nearby, or peaches or things like that. They're going to move from the crops that they prefer to eat and end up in the grapes at the end of the season when that's all there is left to eat, as opposed to spending their whole lives in your vineyard.
That makes sense. Just kind of curiosity aside, do other fruit species see sour rot, or is this something specific to sort of like the Drosophila grape yeast bacteria interaction?
Yeah, that is so interesting. I know that there are other things that are called sour rot in other fruit crops, but they aren't this same fermentation oxidation reaction. And I don't know a lot about the differences that we're seeing. Most of those are caused by more explicit pathogens as opposed to a chemical reaction that is, prone to happen. I think part of that is that the berry is a unique, the grapeberry is unique in that it has this thick outer skin with the pulp pretty well protected, and whereas other berries tend to be pretty fleshy and easy to, contract other things. So as far as I know, this is pretty unique to grapes, but if anybody has other information on that, please tell me.
Yeah. Okay, another question from Gary Schaub is whether you've looked at ozonation as a way to control flies. Ozonation, is that the...
Yeah. No, we haven't. Mostly because there's been so much mixed experience with ozonation, and part of that is that, even in spraying, from anecdotally, people have said it works really well at the beginning of the row, but by the time you get to the end of the row, you're not getting really as much ozone. The other side of that is that I can't speak to ozone in particular, but the perennial problem that we keep facing is that it's not really targeting the flies on the inside of the berries, which I think is where we really need to target. So no, I haven't looked at ozonation, but it's also, there's a lot of conflicting data on ozonation in general.
Okay, that makes sense. I'm just gonna send a quick message out to everybody. If you're asking questions in the chat bar, it's really hard for me to kind of keep track of those. So if you could actually just copy and paste those into the question and answer bar, that would be really helpful for me just to keep track of what's going. So just a quick aside. And then we'll ask a few more questions. Do you mind if we go a little bit past?
No, I'm fine.
Okay, we'll try to make sure to get to everyone's question. But again, if you have something that we don't get to today, feel free to send an email to myself or to Megan. I'll make sure to get those answered. Another question from Steve Amundsen is whether when you were looking at the difference between the VSP and the high wire trellis systems, whether you did any leaf thinning on those two, and if so, was it the same? And also, was there any interaction, or do you have any idea if there would be an interaction between leaf thinning or fruit zone cluster thinning?
We did not do any leaf thinning on either of those. They weren't our blocks. They were a commercial cooperator's block. So we didn't do any management. There was no leaf pulling done though. And if I were a grower, I would try it because I think that anything you can do to sort of open up that fruit zone, I think would be helpful. But it's also, in my experience, not necessarily a silver bullet, but I think it might help.
Yeah, excellent. Yeah, I was kind of wondering about that also, just because I don't know a lot about melanogaster, but from what I know about the spotted wing, that it does seem like that makes a really big difference in terms of the humidity and temperature.
Yeah. Yeah, anything you can do to increase airflow, I think would be helpful.
Okay. Another question, if there's a particular Brix level that's associated with pre-onset of sour rot?
We've mostly seen sour rot after 15 Brix, I would say. So 14 to 15 Brix is really the time at which we start seeing symptoms in the vineyard. And when we did our pre-sour rot sprays as part of our spray trial, we aimed for 12 to 13 Brix.
Okay. And then another sort of life cycle question, whether clusters will continue to develop sour rot if you remove infected berries from clusters at harvest.
If you remove the individual berries.
I think that's what the question is, yes. I'm not sure actually if that's meaning later in that same season or if it's meaning like a future, like next year. So maybe.
Oh, I see. So I think so. Okay, the thing about the infected berries is by the time they look infected, they probably have larvae in them that are, if that is indeed what is causing this, which I highly suspect is, then they've had eggs deposited that have grown into larvae that have eaten around that are then causing this, the fermentation oxidation reaction is happening and we get it all catalyzed by these larvae that are crawling around. So there's no guarantee that a healthy looking berry is not actually in the pre-symptom phases. Does that make sense? Or stage? So
Yeah.
just because it looks healthy doesn't mean it doesn't have Drosophila eggs in it that haven't yet developed into larvae, if that makes sense.
Yeah.
That being said, I haven't met any growers yet who are willing to go through and hand pick off individually infected berries. But if that was something you were willing to do, you could always give it a try. The thing that I would caution is that, if we look at those pictures on the left on my slide right there, picking off some of these individual berries, when you do remove them, their pulp is going to kind of splatter all over the cluster. They don't come off cleanly, so it's not just like, oh, pick them off and you're left with a perfect cluster. Sometimes it's pretty gooey and oozy in there. But, if that's something you're willing to go through, I would let me know how it works.
Okay. Okay, another question about whether sort of trapping out flies is at all a possibility, or whether traps are more likely to remove flies or whether they're more likely to draw them in. Is this like a Japanese beetle situation where you don't want to trap, or just sort of like, there's so many, there's no.
So that is something that we have been talking about, that we are interested in, is some type of attractant / insecticide. So something that will, bring them in and then kill them. But we are really worried about that same thing that you mentioned, that it might attract ones that wouldn't otherwise find their way there. So we are cautious of traps for that reason, because it might even attract them earlier than expected. If they smell like, whatever, apple cider vinegar or something in the vineyard, they might come running. Whereas if you left those grapes alone, maybe they wouldn't even get sour rot. I don't know. But it becomes this tough thing. Attracting flies to your block is kind of we'd like to think that it would work, but it's something we've talked about, but I don't know if we're going to go that direction.
Okay. Let me see. What's another question is about in other systems for insect control. Sometimes there's a use of pheromones to sort of like either do mating disruption or something like that, and whether there's anything that might work with fruit flies.
Yeah,
with
not
pheromone control.
Not that we know of yet, but we are really interested in doing research on that front, and I think my grad student Patrick is very interested in that as well. Is, can we figure out something that would deter them from laying eggs in the grapes to begin with? We're really, really interested in that.
Yeah. Okay. And this sort of goes hand in hand with something we've talked about before, but is there any data on when the Drosophila larvae start to get into the berries? Does that have to do with maybe a Brix level or something else?
Mostly it involves, we start to see it when we start to see splitting. So any sort of entry point, and whether that's splitting because of rain, or we see a wound site because the berries are pushing up against each other. It's really like when the berries are swelling and they're pushed up against each other, and there's that opening either at the pedicel or an obvious wound site on the outside. That's when we start to see the damage.
Okay, and kind of a follow-up on that, Jeremy asked if there's any correlation to amount of rainfall and sour rot, or whether that might have to do with like berry splitting or anything like that that could elevate levels.
Yeah, I'm sure it has to do with berry splitting, because we've often seen that in wet years, and if it's wet in those last few weeks before harvest, that's where we really see sour rot kind of go nuts in our vineyards. So I've mostly assumed that, because I haven't got to the point of doing the research on it yet, that the increased rainfall has to do with the berries splitting, which then leads to wound sites, which then provide a good home for the Drosophila. So, yeah. But we don't necessarily see it in dry years, so that's sort of the trade-off.
Sure. Another question, we're almost done here. Another question is where specifically the larvae and flies are that you would be targeting with the insecticide. Are they actually inside the berry, or are you targeting adults that might be within the cluster or more wide throughout the vineyard?
So with the sprays that we've been applying, these Oxidate and Mustang Max sprays, we're targeting adults. And that's because they're on the outsides of the clusters where we can reach them. Whereas targeting the larvae and the eggs, which are actually on the insides of the berries, that is a much taller order. That is something that we haven't figured out how to do yet, especially that close to harvest.
Yep. Another question, and this one I think maybe we could send an email, a follow-up email with this information if you felt comfortable sending it out, but somebody was asking which varieties did you use in your studies and which had more or less incidence of sour rot. So that might be, I mean, if you want to answer right now is fine, but also if there's a more complicated, maybe we could send an email with a slide or something with.
You mean I assume for the spray trials?
I think that's what they mean, but maybe also just more generally if there's sort of like a list of high versus low susceptible cultivars.
So I'm trying to think if we've used, I think Vignol is what we've used for every set of spray trials. I know that's obviously it's the one we used in Geneva for all the spray trials there, but here in Missouri, both of the commercial cooperators both had Vignol as well. And we know that Vignol is the most widely planted white grape in the state here. So that's why it's such an issue, is that it's highly susceptible. And part of that are just the really tight clusters. Other varieties that I've seen it commonly on, Riesling, Pinot Noir, Cab Franc, Pinot Gris. Trying to think off the top of my head. Those are the ones that come immediately to my mind, but I've seen it on things like Merlot and Cab Sauv, things that don't make any sense. Very random, but generally, if it's a looser clustered variety, it's very uncommon to see sour rot. And if it's a tight clustered variety, and that can go clone by clone too. Obviously Pinot Noir has some really tight clustered variety or tight clustered clones and other very loose clones. So it's very much, your own, what you see in your vineyard.
Sure. Yep, that makes sense.